In this video I'm going to be looking at question 4 from the June 2010 Edexcel FP1 paper. The topic of the question is complex numbers. The question starts by giving us a function, a cubic, x cubed plus x squared plus 44x plus 150, and then given that f of x is equal to x plus 3 and then a quadratic x squared plus ax plus b, we need to find the values of a and b. In the second part of the question, we need to find all three roots of f of x, and then finally to find the sum of those roots. Well, in the first part of the question, there are different ways of doing it, but the easiest way perhaps is to compare coefficients. So if we look at the coefficients of the unit term, or x to the power 0, we can see that on the factorized expression that we're given, that the units term comes from 3 multiplied by b. So 3b must be equal to 150, and therefore b is equal to 50. Doing a similar thing for x to the power 1, the x term comes from 3 multiplied by ax, so we've got 3a, and then the value of b multiplied by x, so 3a plus b is equal to 44. Well, we know that b is equal to 50, so that means that 3a is equal to negative 6, or a is equal to negative 2. The marking for that part of the question, both B marks, so no method necessary. You simply need to get the values b equal to 50 and a equal to negative 2. The second part of the question asks us to find the three roots of the expression of f of x equal to 0. Well, we've done the factorization, we found the values of a and b in the first part of the question, so we've got that f of x is equal to x plus 3 and then x squared minus 2x plus 50. So we're left to then factorize the quadratic part of the expression. Different ways of doing this. One would be to look at it in terms of completing the square, or the other would be to use a quadratic formula, because what we're going to do is to say, well, f of x equal to 0 means that either we've got x plus 3 equal to 0, in which case we have the first root x is equal to negative 3, or we have that quadratic x squared minus 2x plus 50 is equal to 0. And that means therefore that we can write x minus 1 all squared. Remember, then we subtract 1 plus 50 is equal to 0, which means that x minus 1 all squared is equal to negative 49. So that taking the square root, x minus 1 is equal to plus or minus 7i, or x is equal to 1 plus or minus 7i. The same result would come by using quadratic formula, so that the roots are negative 3, 1 plus 7i, and 1 minus 7i. It's straightforward to work out the sum of those, simply literally adding them together. The 7i and the minus 7i will cancel each other out, giving you negative 3 plus 1, which is negative 1. So the sum of the roots for part C of the question is equal to negative 1. There is an alternative way of getting the sum of the roots by looking at the original expression. Some of you will know that the sum of the roots is given by minus of the coefficient for x squared in a cubic. However, simply adding together the values that you found would give you the mark. So the mark allocation there, 4 marks for doing the finding the roots in the first place. Those were allocated as a B mark, so no method required for the x equal to -3. A method mark, whichever method you used, and then 2 A marks for the 2 roots, the 2 complex roots. So that was the 4 marks for finding the roots, and then a further B mark in part C of the question for finding the sum of the roots. That's the end of that question. Further questions for this module and other modules can be found at www.furthermaths.org.uk.